Hello everyone, welcome to our final project presentation. Today we'll be presenting our project titled AI Math Solver Application. Now the purpose of this application is to help users solve mathematical problems more conveniently by allowing them to input either mathematical expressions or natural language questions. Our system combines web technology, symbolic mathematics, and artificial intelligence to provide users with solutions and explanations that support learning. Many students struggle with mathematics because they might not know how to properly formulate equations or understand the reason behind solved solutions. Existing tools often require users to enter problems using strict mathematic notations. Therefore, our goal was to create a system that allows users to ask questions more naturally, such as what is 2 plus 2? Or solve x squared minus 9 equals 0. The application then interprets these equations and provides the appropriate answers. Now, the application consists of three main components. First, we have the front-end, which was developed using Next.js and React. This provides the user interface where users can submit questions and view results. Second, we have the Backend API developed using Express.js, which acts as a bridge between the front-end and the AI service. Finally, we have the Python AI service developed using Flask, SymPy Ollama with the PHI-3 language model. Now, these components work together to interpret user inputs, solve mathematical expressions, and generate explanations. We will now demonstrate the application's solving capabilities. First, users can enter direct mathematical expressions. For example, we can type 2 plus 2, and the application returns 4. The system also supports more advanced mathematical problems. For example, x squared minus 9 equals 0. The application interprets the question and returns the solution -3 and +3. Another feature of our application is support for natural language input. For example, what happens when 3 apples are added to 5 apples? The AI interprets the context and determines that the total number of apples is 8. This demonstrates the flexibility of our system in handling different forms of mathematical questions. In addition to solving problems, the application includes a practice question generation feature. Now, users may generate random mathematical questions for self-practice. This feature encourages active learning and allows students to continuously test their understanding of mathematical concepts. Examples of generated questions include algebraic equations and simplification problems. One of the key concepts of this project is the use of artificial intelligence. We interrogated Ollama, running the PHI-3 language model, into the system. The role of AI is to interpret user intent and convert natural language into mathematical expressions that can be processed by SymPy. The AI is also used to generate explanations that help users understand how solutions are obtained. By combining symbolic computation with language model, the application provides a more user-friendly learning experience. Security was also considered during the development process. Several mechanisms were implemented to improve the reliability of the system. Firstly, input validation was applied to ensure that incoming requests followed the expected format. Second, input sanitation was implemented to reduce the risk of malicious input affecting the application. Third, rate limiting was introduced using Express malware to prevent excessive requests from a single source. This helps mitigate potential abuse and protect system resources. Finally, activity logging was used to record requests and errors, allowing easier monitoring and troubleshooting. Various forms of testing was conducted throughout the development. Functional testing was performed to verify the arithmetic operation, algebraic equations, and the natural language questions produced the expected output. Example including testing 2 plus 2, x squared minus 9 equals 0, and other mathematical expressions. Security testing was also conducted by evaluating the effectiveness of input validation and rate limiting. Furthermore, AI testing was performed to assess whether the language model could correctly interpret natural language questions and transform them into valid mathematical expressions. These tests help improve both the accuracy and reliability of the application. Throughout this project, we encountered several challenges. One challenge involved ensuring the natural language input could be accurately converted into valid mathematical expressions. Another challenge involved interrogating multiple technologies including Next.js, Express.js, Flask, SymPy, and Ollama. Despite these challenges, iterative testing and refinement allowed us to improve the overall functionality of the application. In future iterations of this project, several enhancements can be introduced. These include implementing user authentication, tracking learning progress, expanding support for additional mathematical topics, and improving the deployment strategy for AI models. Personalized question generation based on user performance might also further improve the educational value of the application. In conclusion, the AI Math Solver application demonstrates how artificial intelligence and web technologies can be combined to support mathematics education. Through natural language understanding, mathematical problems solving, explanatory feedback, and security consideration, the system aims to create a more accessible and engaging learning experience for users. This project has allowed us to apply the knowledge and skill gained throughout the course in the areas of front-end development, back-end interrogation, artificial intelligence, and security implementation and software testing. Thank you for watching our presentation.